A very good morning. I would like to greet everyone watching. We are from the group Chocolate Mint, and in this video, we will give a short introduction about unsupervised learning. So, unsupervised learning is basically a learning method whereby additional information about the labels or correct answers are not given to the model. So the questions comes, how the machines can learn without having a teachers or correct answers. One of the answers to that questions is through the clustering concept. Before going further to the clustering concept, we will first look at these pictures. Imagine how we can differentiate between the oranges and tangerines without having the labels of them. We can differentiate them by using the shapes, taste, and textures of both oranges and tangerines. The concept of the clustering techniques is almost the same as this. In short, clustering techniques is a grouping technique of unlabeled data based on the similarities between each other in groups or clusters. Next, we are going to talk about the important properties of the clustering techniques, which are similarity and dissimilarity. Similarity refers to the distance between points in the same cluster. We might also refer to the distance as intra-cluster distance. Our goal is to get the smallest intra-cluster distance as possible, and we can measure the distance using the cosine similarity and correlation coefficients. Next, about this dissimilarity, it refers to the distances between points in different clusters, or we might call it as inter-cluster distance. Unlike the intra-cluster distance, for inter-cluster distance, we would like to get the largest possible distance as possible, and we can measure the distance through Euclidean distance, Manhattan distance, and Chebyshev distance.
What is sum of squared errors SSE? So when we talk about errors, we always keep in mind that the lesser the errors, the better the task. Therefore, in the context of SSE, it means that the more we minimize, the better the clustering. In the formula of SSE, x represents the points of the data and mu is the mean. So let's take a look on the diagram on the right hand side. In the diagram, the red color circle is actually the data point, which is represented by x, while for mu1 and mu2, they are the center point of the cluster, which is also known as centroid. Well, at this point of time, you might wonder, does SSE works well for all types of cluster? The answer is no. SSE only works well for equally sized clusters. In this slide, we can see that the clusters on the left hand side seems like it is well separated. However, they actually have a large SSE. This is due to the fact that SSE might not be able to calculate correctly for the clustering quality if the cluster have different sizes, while on the other hand, the cluster on the right hand side have a small SSE. This is because both the cluster are equally sized cluster and therefore the SSE is reduced. Partitional clustering is a type of clustering. It refers to the divisions of data objects into non-overlapping subsets, which is also known as clusters. Each dataset can only belong to one cluster. An example of partitional clustering is k-means clustering. First and foremost, the number of clusters, which is represented by k, will be chosen based on the user's preference. Step 2. For each k, randomly choose a data point to be the centroid. Step 3. Assign each data point to the cluster closest to the centroid. And lastly, step 4, recompute the new centroids and repeat the calculation steps until the centroid becomes stable. This is an example of k-means algorithm. In this example, the data sets are given and the k is equals to 2. So we will choose 2 data points to be the centroid, which is 4 and 20. Then, using Manhattan distance, we will calculate the distance of each data point with the centroids. To identify which clusters the data points belongs to, we will compare the distance of the particular data points with the centroids and we will choose the shortest distance as the clusters. After identifying the clusters for all the data points, we will calculate the means of the data points in the cluster. The mean value calculated, which is 7 and 25, will be used as the new centroid value for the next iteration. In the second iteration, 7 and 25 are used as the centroid value. Then, repeat the steps and compute the new centroid value. Since the new centroid calculated is the same as the inputs, centroids at points 7 and 25 are the best for these datasets with the cluster numbers k equals to 2.
Hi guys, in k-means algorithm, it is very important to choose the correct k value. We can select the value of k through the following two methods, which is elbow method and silhouette coefficient method. I will first introduce the elbow method to you guys. In the elbow method, we need to compute and observe the difference in drop between the k-value with the data point average distance to the centroid. These values are then plotted into a line chart. When increasing the k-value no longer reduces the average radius significantly, we can consider that the optimal k-value has been found. This point usually appears at the elbow position on the line chart, so that's why we call it elbow method. Next is the silhouette coefficient method, which can be used to measure the accuracy and consistency of clustering result. The value range of silhouette coefficient is between -1 and 1. The closer to 1, the more accurate and consistent the clustering results are. And the closer to -1, the less accurate and inconsistent the clustering results are. We can try different k values and calculate their corresponding silhouette coefficient. And then choose the k value with the highest silhouette coefficient as the best k value. Now, let's talk about the strength and weakness of k-means. The strength of k-means is simple and easy clustering algorithm because it's easy to understand and implement. In addition, it is efficient because k-means algorithm is an iterative algorithm with fast operation speed. Furthermore, k-means algorithm is interpretability because it can help us understand the data distribution and characteristics. Last, because k-means is simple, it is also most popular clustering algorithm being using. For the weaknesses, k-means algorithm is only applicable if the mean is defined. Next, the k-means algorithm needs to specify the number of k-first, which may not be easy to determine for some dataset. Moreover, k-means algorithm is sensitive to initial seeds because the different initial value may lead to different results. Last, k-means algorithm is not suitable for discovering clusters that are not hypersphere because it can lead to poor end result.
Now I'm going to talk about what is hierarchical. So, hierarchical is an algorithm that groups similar objects into a cluster and develop a hierarchical of cluster in the form of tree, which is the dendrogram. So there are two approaches. So for the first approach is the agglomerative clustering or the bottom-up, or the divisive clustering or the top-down. So as for the agglomerative clustering, so this is a graph that from the bottom level build the dendrogram and merging the nearest pair of cluster, so it will stop when all the data is merged into a single point, and when they merge to a single point, which means it is the root at the top. Next, which is the divisive clustering or the top-down. So top-down is a starting from the first point on the top, which is the root cluster, and split into different points, which is the child root, and it will split until it left a single point at the bottom. So on the right, it will show the diagram of top-down approach. So the ABCDEFG is the root cluster, and at the bottom level, the HGF, which is the single root. And next is the agglomerative and divisive clustering difference. So on the left side is the divisive, which means it's from the root to the single point, and on the right side is the agglomerative, so which is from the child, the single point, to the root.
I will now briefly explain how to count for the agglomerative clustering, which is also known as bottom-up clustering. We will use single linkage for the explanation. For the first step, we need to count for the distance between A to B using the formula x1 minus x2 plus y1 minus y2, and fill up the table by applying the formula from A to F. Next, look for the smallest distance, which is 0.5 from D and F. Combine cluster D and F and make them into a cluster. Now cluster DF will have new numbers, which is compare D and F and take smaller distance. Other clusters remain the same. Now take the smallest distance, which is 1 from cluster DF and cluster E. In iteration 4, compare the smallest distance between cluster DF and cluster E and put it into the new cluster. Repeat the steps for iteration 5 and stop when you get only one cluster left. As for the complete linkage method, it is basically same as single linkage, but there's only one difference. You can see the previous example question. We will take the smallest distance, which is 0.5 from cluster D and F, but now we will take the largest distance from the comparison of D and F and put them into the new cluster DF. Not like single linkage, it takes the smaller distance. Other steps remain the same until you get only one cluster left too. This is the dendrogram for agglomerative clustering. It is from bottom to up. The slides are provided in the description link down below. That's all from our group. Thank you.